Hello, class. In this video, I'm going to answer a couple of more questions from your Test 3 review packet. We'll start with problem number 8. It says, find n of 3 and interpret in the context of the situation. So we look at our paragraph up here. So t is the number of years since 2000, and it looks like it approximates the number of dogs treated at an animal clinic each year since 2000. So for the first question, all we have to do is just replace t with 3 and calculate. So let's see if I can pull up my calculator and put that in here. So this is what it looks like in my calculator. I press enter and I get 357. So 3 years after 2000, so we'll call that 2003, there were 357 dogs that were treated at the animal clinic. All right, so here's number 8. I kind of typed it up nicely. Question 9 says, what is the vertical intercept? Now be careful. At first, you think it might be 50, but there's a 3 out here. So I might want to rewrite this problem to look like this. All right, so I rewrote the problem. You see what I did is I distributed the 3 all the way through. So now I can see my vertical intercept is that 150, right? Because when we have a function in the form of ax squared plus bx plus c, the c is your vertical intercept. Okay, so for number 8, I'll write it as an ordered pair. Whoops, not number 8, sorry, number 9. So I tried to type that up a little nicer for number 9, right? Vertical intercept is 0, comma, that should be a comma, 150. The initial number of dogs in 2000, because that's my base year, was 150. Practical domain for this problem. There's many correct answers. Think about how long is this model good for, right? So, I don't know, maybe the model's good for 10 years or 15 years or 20 years. So I will say my domain. So I put our domain, x is somewhere between 0 and 15. And I guess I could have used the letter t because they use the letters n and t. So maybe t is between 0 and 15, right? And again, you could have said 0 and 20. How long do you think this model is good for? Some might say 10 years, 15, 20. There's no wrong answer. Now, if you put 0 to a million, well, that'd be a wrong answer. But 10 years, 15 years, 20 years, I'll accept any of those answers. All right, use your calculator to graph this function. Right, so I'm going to enter this into my y1. Right, so I entered 3x squared plus 60x plus 150. And my window, I went from 0 to 15 years, right? And then from negative 10 to 1500, right? This is really my first stab at it. Now, you might say, why did I go negative 10? Sometimes I like to see what's happening below the x-axis. So I press graph, and nothing special, but that's the graph. Let's see, what else do they ask us to do? In terms of the labels, right, the horizontal axis was my t, the time since 2000, right, number of years since 2000, and my y-axis, or my vertical axis, was the n, the number of dogs, okay? Now, let's see. Question 12. Use the graph to determine the year that the clinic treated approximately 525 dogs. All right, so if I go back to my y equals and I add 525, I can press graph. The intersection will be my answer, right? I want to know how many years go by till I get to this value of 525, right? If this is time, how much time goes by for the value to be this 525, right? Because remember, the red line is the 525. So we have to get the intersection, right? So I press second, and then the trace key, number 5, enter, enter, enter. So it looks like it takes 5 years, right? X equals 5, right? right? So as an ordered pair, it'd be 5, comma 525. If you're taking a test and you're writing this on paper, your teacher would want to see your method. So this is my method, me graphing. So I'm including a sketch of the graph. Okay. Let's take a look at problems 13 to 17. It says simplify each expression. Okay, so let's try and do that. 13, I want to distribute to get rid of the parentheses. So we have 6x to the 5th minus 8x to the 4th plus 2x cubed. Right, that's this first part. And then we take this negative x and distribute that. Right, so we get minus x to the 5th minus 3x cubed plus 5x. Right, negative times a negative is a positive. And then combine like terms where you can, right? We can put those together to get 5x to the 5. What else do we have? Minus 8x to the 4. We can combine the cubes, right? That becomes minus x cubed. And what else do we have left? Plus 5x, right over here. That's my final answer. Okay, I'm going to erase this and then do question number 14 in this area over here. So for number 14, we're going to use FOIL, right? Because we're multiplying two binomials. So let's rewrite this over here. So for number 14, we're going to do our first terms, right? That's the f in FOIL, right? So that's 3x squared. The O in FOIL is the outer terms, so that's plus 6x. Then the I in FOIL is inner terms. And then the L in FOIL is the last terms. And when we combine our like terms, you get 3x squared plus 5x minus 2. That is my final answer for number 14. Okay. Number 15, again, we're going to use FOIL, F-O-I-L. Our first terms are the x squared. Our outer terms would be minus 8x. Inner terms would be plus 8x. And the last terms would be minus 64. The 8x and the negative 8x will cancel, leaving me with x squared minus 64. Okay. So let's take a look at number 16 and 17. So 16 is just repeated multiplication, right? So this becomes x minus 5 times x minus 5. And again, if we use FOIL first, outer, inner, and last. When we put this all together, we end up with x squared minus 10x plus 25 for number 16. Okay, and now for problem number 17, it's a little bit different, but really we're going to just distribute the x all the way through. So when I do that, I get x cubed plus 2x squared minus x, right? That's me distributing the x all the way through. Just double checking, it looks good. And then we're going to distribute the negative 4 all the way through, right? Boom, boom, boom. So this becomes minus 4x squared minus 8x plus 4. And then kind of combine like terms where you can. So The x cubed, there's nothing we can do with that. But I have a 2x and a minus 4x squared. I'm sorry, a 2x squared and a minus 4x squared. So that leaves me net negative 2x squared. What else do we have? I have a minus x and a minus 8x, so that's a minus 9x plus 4. And I think that's all we can do with that. Yeah, that's your final answer for number 17. So I'm going to stop here, and in the next video I'll try to work through problems 18 to maybe 28, and we'll see how we do. All right, thank you for watching. I'll see you in the next video.